Hello everyone. Our today question is related to the topic interference of waves. Now the question is in front of you. Let me read the question. You can see the question on your screen. Two current sources produce waves of different intensities which interfere. After the interference, the ratio of the maximum intensity to the minimum intensity is given 16. What is the ratio of intensity of the waves? Now return back to the board. Okay, now we solve the question. In the question, this is given the ratio of maximum intensity to the minimum intensity in an interference between two waves is given 16. We already know that from the concept of interference, when two waves are interfering, their resultant intensity is depending upon the phase in which they are meeting. If they are meeting in the same phase, then the intensity is maximum, and if they are meeting in the opposite phase, the intensity is minimum. In other words, intensity is also directly proportional to the square of the amplitude, that can be considered as I equals to K A square. If we, for this question, if we consider there are two waves having the intensities I1 and I2, so the resultant maximum intensity must be equals to K under root I1 plus I2. When the amplitude is maximum, the intensity is maximum, and I minimum must be equals to K A1 minus A2 whole half square. When the amplitude is minimum, the intensity is minimum. So in other words, we can write here A1 plus A2 whole half square divided by A1 minus A2 whole half square is also 16, and also I equals to K square. According to this, A equals to under root I upon K. So at the place of I1 we can put under root I1, at the place of A2 we can put under root I2, and its square, once again I1 at the place of A1, under root I2 at the place of A2, and its square is 15. Taking square root on both sides, we have this under root I1 plus under root I2 divided by under root I1 minus under root I2 is 4 by taking the square root. Now under root I1 plus under root I2 is equals to 4 under root I1 minus under root I2. On solving this, we have 4 under root I1 minus I1, this is 3 under root I1 is equals to 4 minus 4 I2 under root I2 plus I2, this is 5 under root I2. So the ratio of under root I1 to under root I2, this 5 upon 3. 5 upon 3, so squaring on both sides, we have I1 upon I2, square of 5 is 25, square of 3 is 9. So the ratio of intensities of waves interfering together I1, I2 is 25 by 9, while ratio of their maximum and minimum intensity is 16. So this is the solution of this question. So now that's all for today. Now we will meet in our next class. That's all.